Okay, welcome to Bamal Math. So in this lesson, we're going to do solving absolute value inequalities. In a previous lesson, I did absolute value equations. Now we're going to work on absolute value inequalities. Now, remember that from the absolute value equations that we're going to have to set up a positive and a negative case. Also, because we have an inequality, we're going to deal with and or statements. So I'll show you how to write the answer on a number line and then do that interval notation as well. So let's go ahead and start with this first one right here. Now, remember that you want to isolate the absolute value before you set up your positive and negative case, but that's already done here. So we can go ahead and just set up our positive and negative case. So this would be x minus 5 is less than 2. And then for our negative case, that's where you got to be careful, because remember, you get rid of the absolute value, you negate the right side, but because it's an inequality, when you multiply or divide by a negative, you got to flip the inequality. So when we negate the right side, we got to flip that inequality. So this is going to be x minus 5 is now greater than negative 2. So we're just going to go ahead and solve those two. So I'm going to add my 5. So that gives me x is less than 7. And then here I'm going to add the 5. So I get x is greater than 3. So now we can take a look at this on a number line. So when we do that, put 0 over here, put 3, put 7. So now if you recall, there's no equal sign with the inequality, so it's going to be an open circle. And then we're just going to follow our inequality. So x is less than 7, so that goes this way. And x is greater than 3, so that goes this way. So you can see they meet in the middle. That's an end statement because they meet in the middle. And I can tell that because this absolute value is isolated, it's by itself, and this is a less than or it's a less than equal to. When that happens, you have an end statement. So here is our number line. But remember, with an end statement, we have a compound inequality. So if it happens to be a multiple choice question, you probably wouldn't see the answer this way. The way you would see it would be like this. So 3 is less than x, which is less than 7. So you can tell these are the same if you read it. X is greater than 3, x is less than 7. So just be aware of that. Some students get confused because they see this, or they see this as the answer, and it doesn't look like what they have here. So just be careful. Now we're going to do this in interval notation. So remember, with interval notation, you just basically take in a number line and you're going to go ahead and put that in interval notation. You're following it. So you start from the left to the right or from least to greatest. So we're starting at 3, not including it, and going all the way up to 7 and not including it. So if you're not including the value, it's parentheses. So with a 3 all the way up to 7, parentheses because we're not including it. And that is our interval notation. Okay. So let's take a look at number 2 here. So we don't have the absolute value isolated, so we got to do that first. So we're going to go ahead and add 1. So that's going to give us the absolute value of 3x plus 9 is less than or equal to 18. Now I can go ahead and set up my positive and my negative case. So for the positive, I get 3x plus 9 is less than or equal to 18. And then for my negative, I get 3x plus 9 is now greater than or equal to negative 18. Remember, you got to change the sign, and then you got to flip the inequality. So now I'm going to go ahead and solve these. So I'm going to subtract 9. So 3x is less than or equal to 9. Divide by 3. So x is less than or equal to 3. And then over here, same thing. I'm going to subtract 9. So I get 3x is greater than or equal to negative 27. Divide by 3. So I get x is greater than or equal to negative 9. So I got x is less than 3, x is greater than or equal to negative 9. Let's take a look at a number line to see what we got. So put negative 9 here, put my 0, and my 3. So both of these are going to be closed circles, right? Because you got the equal sign there. So it's going to be closed and closed. So x is going to be less than or equal to 3, which goes this way, greater than or equal to negative 9, which goes this way. So again, they meet in the middle. It's an end statement. So I want to go ahead and write this as a compound inequality. So I'm just going to go ahead and say negative 9 is less than or equal to x, which is less than or equal to 3. Put that right in there. So you can see if you read x is greater than or equal to negative 9, that's the same, less than or equal to 3, and you got that there. And then for our interval notation, remember that starting all the way on the left side, we're including the values, so it's going to be a bracket. So we're going to have a bracket. It's going to be negative 9 going all the way to 3 with a bracket. And there is, so you got your number line, inequality, and then we have our interval notation. All right, let's look at the last one right here. And this is always tempting. Students want to go ahead and do the 10 plus 6 and say it's 16, which we cannot do that. So we got to get rid of the 10 first and then divide by 6. So I'm going to go ahead and do that. So subtract my 10. So I get 6 times the absolute value of this, which is greater than or equal to 72. Now I'm going to divide by 6. So I get the absolute value of 2x minus 4 is greater than or equal to 12. Now I can go ahead and set up my positive and negative case. So for my positive, I wind up with 2x minus 4 is greater than or equal to 12. And then for my negative, I get 2x minus 4 is less than or equal to negative 12. Remember, you negate and then flip your inequality there. So now I go ahead and solve both sides. So I'm going to add 4. So I get 2x is greater than or equal to 16. Then I'm going to divide by 2. And I get x is greater than or equal to 8. Then I'm going to do the other side. So I get 2x is less than or equal to negative 8. And now I'm going to divide by 2. So x is less than or equal to negative 4. So I can go ahead and put this on a number line. So I have my negative 4. I'll put 0, put 8. Both of these are going to be closed circles. But now look what happens as opposed to the other two problems. X is greater than or equal to 8, so that goes to the right. X is less than or equal to negative 4, so that goes to the left. So this is an OR statement. And I actually knew that when I got here because I have the absolute value by itself and I have a greater than or greater than or equal to, so I know it's an OR statement. So then for my answer, I just go ahead and put an OR here. I don't have to rewrite it like I did this over here. I can just put an OR right there. Then I have my number line here. And then the only thing we have to do is interval notation. Now, if you recall from the other lesson, when you have an OR statement in these two separate intervals, we have to list those two separate intervals joined by union. We're going to use a little u to represent the union of them. So we're starting all the way on the left side, which is negative infinity here. All the way on the right side is positive infinity. So we're going to start there. So negative infinity all the way up to negative 4. And we're including 4, negative 4, excuse me. So we're going to go ahead and put a bracket there. Union. I'm going to join with this over here interval. So we're starting at 8 and including it all the way to infinity, which causes a parenthesis around infinity. So there are our two intervals right here. So you got basically negative infinity to negative 4 for this interval, and then 8, including 8, all the way up to infinity for this interval. Okay, so hopefully you enjoyed this lesson. I have many other lessons on my YouTube channel at Bombalo Math. And like my first period used to say, make small choices. See you next time.